there, welcome to Extreme Academy. This is where we're going behind the scenes in our exciting relationship with the KICK Sauber Formula One team. This is part two. We already did part one a couple of months ago, earlier in the F1 season, where we went behind the scenes and looked at multicast, one of the technologies in use in Formula One, and our relationship with the KICK Sauber team. And this is part two. So with the same format again, we're going to have some chat about Formula One and the relationship. And then we're going to get into a technical topic, which this time is all about wireless and 6 gigahertz. So this is our agenda today and our speakers. So we're going to start off with Marco Martoni, who's going to bring us up to date on how things are going with Sauber and our relationship. We then got a special guest. It's something we recorded a few weeks ago. It's an interview with the senior network engineer at Sauber. So we're going to get a perspective of what's life like as a network engineer. Then we're going to bring in Roy, and we'll have a little bit of chat about life in Formula One. And then Roy's going to take us through the technical training topic for today, which is all about 6 gigahertz. And then we'll wrap up with some further training suggestions and close out for the day. It says training, so we've got to always have a learning objective. So by the end of this session, you should understand 6 gigahertz wireless technology at a high level. It's a complicated topic, but we're going to cover this at a high level and talk to you about how has Wi-Fi evolved over the years. This is important if you have to explain it to somebody else. Maybe you're trying to justify a project or explain it to your team. And within that, you'll be able to explain 6 gigahertz spectrum and worldwide considerations. Now, that's what we're going to do today. And then in the next session, we're going to take that into a more practical environment, and we're going to talk about a wireless survey in the F1 pit garage. So if we can actually get into the garage and do that live, we're going to do it. If we can't pull that off in time for the next one, we will we'll be doing that through some theoretical visualization. So that's what we've got in store for you today. I'm going to bring in Marco as our first guest today. How are you doing, Marco?
Hey, Rowan. I'm doing well, thanks. How are you doing?
Very well. So just kick us off today, Marco. Tell us, what's happening at Sauber. What's happened since we last met with the audience here?
Yeah, well, as you know, a lot is happening in the world of Formula One. It's a very fast-paced environment. So we've had the last session, I think it was 2 months ago in April, and just shortly after that session, there was a big event, a very important Grand Prix happening for the team in China after a 5-year pause due to the pandemic. They went back to China, obviously with the KICK Sauber team having the very first Chinese F1 driver. This was a very huge event for them. You can see it here on the picture with Joe as he parked the car after the race on the main straight and got the big applause of the audience. Even if he didn't win, he didn't score any points, unfortunately. I think they were pretty strong in that race, but it didn't work out at the end. But still, overall, it was a fantastic moment, I think, for him, for the team, and obviously also for us being a partner and being present with the team.
That's great. It was great to see. Very emotional for him, and awesome scenes. What else, Marco? What else is happening?
Yeah, I mean, again, you see another person on the picture, and F1 fans amongst our viewers here will recognize this is Nico Hülkenberg, currently driving for the Haas F1 team, and it was announced also in April that he will join the KICK Sauber team as of next season for a multi-year contract leading into the Audi F1 area, which I think is another, just great combination of a German car manufacturer, a big one like Audi, and a German driver. So I think this is exciting news for the team. Again, also for us, knowing that we have Germany as one of our big markets to have the German driver in the team that we're partnering with. So yeah, very, very exciting and interesting times ahead, I would say, as the team is transitioning to the Audi F1 team. Yeah,
great news. He's an amazing driver, so we've got a lot to look forward to. What about the relationship, Marco, with Sauber, between Extreme and Sauber? What's been happening?
Yeah, so we're continuously working with the team on joint activities, and one good example was actually happening just a week ago in Hinwil at their headquarters close to Zurich in Switzerland, where we did our Extreme Now custom event at the premises of Sauber Motorsport. So we welcomed more than 100 people in their event facility, which is a fantastic area. It is basically where the wind tunnel is located, and in that same building they have state-of-the-art event area. So we were lucky to be able to host our event there. We had Sauber CEO Andreas Seidel. You can see it on the picture on the top. He was interviewed by Markus Nispel on our side, talked a little bit about the vision, the transition that is going on over the next months into that Audi team, but then also about the importance of data in a sport like the Formula One, right? So that was also very interesting to hear it from the CEO of that company. Obviously, we added some of our sessions, gave technical updates to our solutions during that event by our team. So it was really a great opportunity to host it at a fantastic location and talk about the partnership and the use case of the KICK Sauber F1 team.
And is this the sort of thing that we'll do again, Marco? Are there other opportunities, do you think, in the future in this relationship?
I mean, the Extreme Now is a global event series. We then have our annual user conference, Extreme Connect, that just happened, that will come back in the next year. So I think the call to action really is stay up to date on extremenetworks.com on our event section, see if there is an event happening near to you, and please join us, because with those events, we're trying to do them in great locations. Obviously, last week was perfect with this partnership, but even around the world, we're hosting those events in very cool locations, and it's a great opportunity for people to stay up to date or get updated about the latest from Extreme Networks.
Okay, fantastic. Thank you, Marco. We'll keep you bringing back into these sessions just to keep us updated on what's happening and other opportunities for people to get involved in this relationship going forward. Okay. Thank you, Marco. We're going to shift gears now. We're going to hear from Hugo, and Hugo is a senior networking engineer at Sauber, KICK Sauber Motorsport, and we got a chance to interview him and talk to him, and we asked him to give us his perspective on life as a network engineer, and also tell us what is life like in race week. So this video interview is about 4 minutes long, so we're going to play it, and then when we come back, we're going to have a chat with Roy and talk about it.
My name is Hugo Drössler. I'm working for Sauber Formula One KICK team. I'm here the lead network engineer for Sauber, the team, and we're stationed in Hinwil, the beautiful city of Switzerland. We are building a car from scratch. That means we build every component except the tires, brake discs, and maybe the brake pads, all in-house. That means we have aspects of network performance that's unseen in other industries or in other institutions. We're dealing with manufacturing process, engineering, design, aerodynamics, wind tunnel, telemetry, heavy data, 3D. And all these components, all these machines, they need heavy-duty networking equipment to handle the data, the streaming, the performance of it. So F1 networking is quite a different monster. F1 also has a slight difference to the network because we're not dealing with a network within headquarters. Our network needs to be securely extended to every racetrack in the world at every race weekend. It means our network is very dynamically built. We're breaking down a network in Bahrain. The next day, the network has to be up in Melbourne, and then in Suzuka, then in the US. Each continent, each racetrack we go, we have an extension of our network. And we are very reliable on this network. If we don't have that network, we don't get data. We require the telemetry data coming up. And if that is not here, our local engineer in headquarters cannot do changes or do recommendations what needs to be done to get that one more tenth, one more hundredth in this one turn to make one more position on the grid to get into the next queue. Race week, okay, you have race weekend, usually, depending on the country, Friday, Saturday you may race. Some countries you cannot race on Sundays, so the race is Saturday. Sometimes you have to race on Sundays. The week starts with, for the networking people, on Tuesday, the race team will be on site. On the racetrack, they'll get the containers, they'll set up the equipment, they fire everything up, and on Tuesday night, depending on time offset, they may work all night, and then we come in the morning, we have an exchange of communication, what's working or what's not working, or some people, the local race IT group here, they may be here at 2 in the morning, helping with the setup if something's not going, looking if the network is connected up accordingly to the racetrack. Is the data flowing? Is it stable? Is it usable? Is the system up? We have a checklist. We go on through, check all the systems, everything what there is, everything from telemetry to communications to data exchange. It gets checked. And then by Wednesday, usually there is, from the FIA, they allow then the first fire-ups and tests and stuff just to see if everything works. And at that point, it's still high stress level for all to make sure, because now that's the first time the car is on the track. We're getting data, we're getting this, does this function, does that function. And then as then Thursday, Friday comes around, you have FP1s, FP2s and stuff like this. At that point, you hope that whatever you did in the last 2 days, it works and everything is, and then the race and the practice starts and you probably can kick back and enjoy the race like everybody else. Not so, because you still have to watch the bandwidth, you have to look if the telemetry coming in, you have to look with the operations engineering here, because we have, here in headquarters, we have an engineering department in the operations room. The operations room is observing the same data as the engineers on the racetrack. So the data brings the data, the car brings the data back to the garage, and the same information is sent up here. And if that network is unstable, the engineers here cannot make suggestions or changes and stuff like that. So from a Tuesday until a Friday, it's a build-up, a checklist, going through, make sure the system runs, everything is fine. And at that point, you hope for the best in the grid position.
That's Hugo. Hugo is a senior network engineer at Sauber Motorsport. Fascinating to hear him talk. I'll bring Roy in. Talking of network issues, Roy, if you see my video freezing, I think that's okay. A line. So I'll keep going. Every now and again, I lose a few frames from my local connection. But welcome, Roy. I mean, as you watch that, Roy, you've met Hugo. You've got behind the scenes in what's going on in the network and what we're doing there. So, give us your perspective on that before we get into the training. What do you think? Do you want to add to what Hugo was saying?
The one thing you learn to appreciate when you actually have the opportunity to go behind the scenes, in this case of, KICK Sauber Formula 1 team, you start to realize the science behind the car and behind the results and the speed. It's, I've said it before. I think I said it in the last session, right? Formula 1 is not just 20 cars or 20 guys crazy enough to do 200 miles an hour around a racetrack. There's a lot of meticulous planning happening. And I think once you understand that and you see what these guys are doing to shave off a tenth of a second or half a second, take corners more efficiently, and, the planning that goes into that, it's not just somebody deciding to hit the brakes 0.1 seconds faster or sooner or later. It's all done with data in mind. They have the ability to mimic a track setup in any circumstance, in any weather condition. They can adjust the car with different, heights of the floor. Different tires have a different outcome. But it's also the state of the driver that has an impact on how the result, how they're actually going to finish the race, or whether or not score points.
Yeah.
And if you draw the parallel to our world, Rowan, which is and also most of our viewers, you look at it from an IT perspective, it's kind of similar, where a racing team is trying to, like I said, shave off tens of seconds or seconds and improve faster lap times, get better results. We do the same thing, right? From an IT perspective, things like, are you going to upgrade your switches, and just do it because the vendor, in this case Extreme, we have a new software version for our switches or AP. So you just click the button and click OK. No, you're not, right? And depending on the type of customer you are, it requires meticulous planning, like detailed planning. Is, let's call it strategic planning. That's what a Formula One team does, right? They analyze the data, assess the competitors. There's a strategy behind it. Of course, there's weather conditions that sometimes are 100% spot on. Sometimes the rain just passes the track, and then that has an impact on the decision on which tires you use. And it's the same on our side with regards to updating and upgrading our switch infrastructure or wireless infrastructure. What's happening? Why are we doing it? Do we actually need these improvements? Right? Sometimes we add new features. Do we actually need those features? So there is planning. There's also this concept of understanding the rules. Right? Some companies have very strict rules on change windows. Right? I know of customers that have one change window a year, which means you can make changes to the network once a year. It's the same with Formula One. They cannot just do whatever they want to do. Otherwise, we would probably now, by this time, we would have had cars doing 500 miles an hour, but we don't. Right? There's rules to weight. There's rules to speed. There's rules to horsepower that comes out of the car, and the car has to fit certain, a certain size. It has to fall within a certain, let's call it boundaries. And it's the same with network planning and network and IT. Verification and validation, the continuous improvement that you're trying to make. Any CIO will ask one question to start with: do we really need to do this? Because in some environments, as we both know, Rowan, there is definitely a need for improvement and there's a need for enhancement. But if the enhancements are not adding value to the overall business outcome, or if there's no efficiency gains, or if there's no improvements on, productivity, then the question that's going to get asked is, well, why are we doing this? So again, there's a whole process behind it. In 20 years ago, I was one of those people. There's a new version out there. Click update. But that was at the time where, every AP was just an AP. Nowadays, an access point is part of an ecosystem. It's part of an entire infrastructure from a company perspective. So updating it may have impact on connectivity, may have impact on efficiency, may have impact on speeds and feeds, which then ultimately has a snowball effect if the update is not done correctly or not planned correctly. It may have a massive impact on your store network or your hospital network, or if you're a school, your students cannot connect, which means they cannot access learning material and training material, and therefore, what are you going to do, right? So it's amazing to see how Formula One deals with this, and it's amazing to see how Formula One keeps pushing the boundaries of technology. I mean, just leave it to a Formula One team to take a technology like Wi-Fi and like squeeze every last drop out of the lemon, which sometimes can be challenging. But for me personally, as a technology enthusiast, as a racing enthusiast, it's amazing to see. It's like, bring it on, right? Let's see what else we can do as Extreme to improve our
great perspective, Roy, and good segue into wireless. We're going to talk about squeezing more juice out of that wireless spectrum with 6 gigahertz. That's the topic. We'll hear a little bit more from Hugo at the end, so stay tuned for that. Get his perspective on how he learns in this environment. Let's just remind everybody where we are on the agenda. We've just heard from Hugo. We've now got Roy, and Roy, for the rest of this session, about the next 15 minutes, is going to get into the technical training topic, which is 6 gigahertz. So Roy, I'm going to bring your slides up, hand it over to you. I'll go off camera for a bit, see if I can sort my camera out, and then we will. Then I'll come back. We'll wrap up and close out the session.
Sure thing. So when we talk about Wi-Fi, and we talk about how Wi-Fi has found its way into, let's call it, society. I mean, think about it. 20 years ago, it wasn't a topic. If you had Wi-Fi, it was nice to have. Nowadays, we have all these, critical applications that rely on wireless connectivity. We have meshing, whereby companies leverage wireless connectivity to extend the wireless network. Right? I guess in the old days, you would call it a repeater, where it repeats the signal. In our current world, right, we call it mesh. And it can have some pretty interesting use cases. Like, for example, recently I had a customer that was extending the network across the street. They had a building on one end of the street and a building on the other end of the street, and they didn't have the means to pull wires. You cannot just pull wire over the street, because it will get destroyed by cars running over it. And there's no way to easily or cost effectively do this. So meshing is being used to extend the network to the other side of the street. Then there is the need for high performance. All these applications bring a lot of challenges onto the network with regards to speeds and feeds, right? Like I said, 20 years ago, you may have, depending on the size of your company, you had 10 client devices on the network, maybe 100, depending on the size of your building and the size of your workforce. Nowadays, everything is connected, right? This is where also IoT comes into play. We got sensors, monitoring temperature. We got CCTV cameras that are connected. We've got voice over Wi-Fi. We've got screens everywhere where broadcasts are playing. Could be advertisements. It could be broadcasting of CCTV camera images over the air. Hitting a screen at some point. So if you look at it from the perspective of where Wi-Fi currently is, and then we segue into a little bit of history lesson as to where Wi-Fi used to be. If you flip to the next slide, a lot of people don't know this, and especially the younger audience that doesn't realize this, but Wi-Fi has been around for the better part of 3 decades, and it started with the 2.4 gigahertz band, where you had 11 channels, but effectively you can only use 3, which was 1, 6, and 11. And the reason for that was those channels are logically separated. One channel does not interfere with the other. And then as time progressed, we added an additional frequency to it, which was the 5 gigahertz band. More capacity. There was more spectrum available for devices to connect. It required new types of devices as well. And with that also came new types of applications. More and more companies started to realize that Wi-Fi was, I guess, from a connectivity perspective, the way forward. Imagine an iPad. You have to plug it into a wire, right? So what was the primary connectivity method for an iPad back in the days, or any tablet? It was the Wi-Fi. And then people started adding, or companies actually, vendors started adding, next to a 2.4 capability, they started adding a 5 gigahertz capability. Now, for many, many years, this has been the way forward, right? This is what we did. We had 2.4 gigahertz with the 3 channels. We had 5 gigahertz, and depending on the country, depending on where you were in the world, you had more channel, more capacity. And we're now in 2024, and Wi-Fi has received another, let's call it update or upgrade, if you will. We added an additional frequency band to it. And why is that? It's because the 2.4 and 5 gigahertz bands are congested. They're full, right? Those, if you compare it to roads and highways, then you could say that the highways are constantly full. I mean, you can drive, you can get to where you need to be, but there's no more capacity to expand. There's no more capacity to be more flexible. So the Wi-Fi Alliance and the IEEE, they came up with a new way of doing Wi-Fi. It's not really a new way of doing Wi-Fi. It's an additional highway system that they built, which is the 6 gigahertz spectrum. So again, 2.4, 5 has been there for for the better part of 25, 30 years. And now, most recent, we added the 6 gigahertz band. And if you transition to the next slide, Rowan, what the 6 gigahertz band gives us is a new road system, or basically a new highway with 59 lanes. Very technically, and we will dig into that a little bit deeper in the upcoming sessions. It's a new highway. It's got 59 lanes, aka channels. It's got a spectrum availability of what we call 1200 megahertz. So there's a lot more capacity there. It has a way better traffic management system behind it. So the technology behind it and the science behind it is leading to better traffic management, traffic handling, low latencies. It's cleaner, and it has enhanced security options that are built into it. So this more spectrum gives us more room, so to speak, up in the air. So if you transition to the next slide, I'll show you that'll show you the kind of like the highway. If you look at the top one, the little pink one, which says 20 megahertz, there's 59 channels in there. And if you then if you go down the stack, you can see that we can do something what we call channel bonding. So we can basically bond channels together to get more capacity out of them. And the expectation is that more and more high-end laptops, high-end devices in general will start supporting that channel bonding mechanism as well, which means that you can actually squeeze a lot of gigabits out of Wi-Fi connectivity. And remember what I mentioned, 2.4 gigahertz. At one point, we were at the dazzling speed of 11 megabits per second. Nowadays, we're going into the gigabits per second, and that is a massive shift in reliability and speed, and delivering that to a user. Now, while I say this, that there's 59 channels available, something to take into consideration and something to keep in the back of your mind, as with Formula One, right? To kind of draw the parallel with that, there's rules, and not every country is the same. If you go to the next slide, you can see that, for example, the United States and Canada have adopted the full spectrum of the 59 channels, the full 1200 megahertz, fully adopted by the United States. And there's a few other countries around the world that have adopted the full spectrum. If you look at, for example, Europe or parts of Asia, there is not a 100% adoption. So in Europe, for example, there is only a specific set of channels available. And it also depends on the country. And then there's also a difference between what you can use indoors versus outdoors. And then there is also indoors, there's rules and regulations around it. So just so we manage the expectation and we set the expectation, if you're a European customer or a European partner and you want to deploy a 6 gigahertz infrastructure with your customers, then you need to understand that it's not the full use of the 1200 megahertz of spectrum. But as I said, we'll go into more details in the upcoming sessions regarding 6 gigahertz, because it will get a little bit more complex from a technology perspective. Like I said, there's all kinds of rules you have to abide by. There's all kinds of things beyond your control, so to speak, that needs to be considered. But at the end of the day, 6 gigahertz gives you a much cleaner spectrum. It gives you that highway system that is going to be a lot less congested. I guess you could say it's a matter of time, because we said the same thing 15, 20 years ago about 5 gigahertz, that it was a clean spectrum and it was amazing and it was all good. Life was fun back in those days. But over time, a lot more devices got connected to the internet, so to speak. 20 years ago, nobody thought about connecting a watch to a wireless network. People did not think about connecting heating systems and thermostats, televisions, gaming consoles to the network. And nowadays, if you look at it from an enterprise perspective, everything is connected. It was recently brought to my attention, which is a kind of a little bit of a funny thing to mention here, but it was the connected carpet. When I heard about that, I was like, what? Now I researched it. So there's carpets with built-in LEDs that in case you want to go to a toilet, you take the app on your phone from that specific venue and you say, I want to have a toilet. It will know where you are because of location-based services. And then there will be arrows showing up on the carpet, guiding you the way to the toilet. Or in case of an issue or some kind of event happening in the building, and you need to find the quickest way out, the carpet will actually guide you to the nearest exit of the building, so you can safely exit. So again, just to recap, 6 gigahertz. It's a cleaner spectrum. Regional differences do apply when it comes to the full use of the entire spectrum. It is from a traffic management perspective and an efficiency perspective, there's a lot of enhancements that came to Wi-Fi with this addition of 6 gigahertz. There's more and more. I guess I wouldn't call them better, but I would call them more options when it comes to security. It's a lot more robust. It's a lot more efficient. And I think one of the bigger changes from a technology perspective, this promise of multi-gig capabilities on the wireless side is actually coming through right now. So what we see in my personal testing environment, I have seen speeds of in the range of 2 to 3 gigabits per second, which now means my 1 gig port is my choke point. It's my bottleneck. So multi-gig is also a part of that conversation. And one other thing, Rowan, to keep in the back of your mind is that when you start using premium APs, for example, when you start using the 5000 series APs on the extreme side in our portfolio, then PoE Plus is a must. So if customers still have older switches and they're still running fine, but they are what they call 802.3 AF powered, which is the 15.4 watts max, then those APs will not function properly. So you will need to look at upgrading your switch infrastructure as well. But ultimately, 6 gigahertz is a good news story to Wi-Fi, and I think we'll see a lot more applications coming to Wi-Fi over the next coming years. Like I said, think about the funny idea of having a connected carpet. Imagine your connected couch, or, I guess you could say connected refrigerators and ovens and dishwashers and washing machines are already there. But, imagine everything in your house from the doorknob to the, to the light bulb being connected, and you can control everything. And all of that needs a transportation layer, which in this case is in our case, it's Wi-Fi. And all of that needs to be handled and segmented and secured and and made as efficient as possible. So the next sessions will hopefully start to dig a little bit deeper, and I would also highly encourage to watch the sessions that we've done with David Coleman, who is an absolute authority on wireless. He's an author of many of the technology books. Really knows what he's doing and what he talks about. I would highly recommend everybody to go back and look for those recordings if you want to learn about 6 gigahertz.
Thank you, Roy. Love the carpet idea. If somebody hasn't done that yet, then I'm sure we'll be walking across those soon. I've got one question for you. By the way, I couldn't fix my camera, so I didn't want to disconnect it. I'm going to keep. I'm going to go with it. So if you see me freeze, don't worry about it. I'm still here. Just bring this back to the world of Formula One. You talked about high intensity applications and the need for this bandwidth to be available. Have you got an example? What's an example in Formula One where wireless communication needs its own road to make sure?
Yeah, I mean, if you look at it, pick your racetrack. Right, there is 20 cars. There is 10 race teams. Then you have the Formula One organization, which is the FIA. Then there's press. There is the local ISP, who may sponsor the event, and they have put some stuff up. Then there's all kinds of people running around the racetrack with, hotspot connectivity, like all these press photographers. Everybody's trying to, run around and make pictures in the heat of the moment. Your picture ending up in the newspaper first, right? That makes money. People are, everything is connected. And if you are then a Formula One team and you're connected to a 2.4 or the 5 gigahertz band, chances of you using the same channel as the one next door or the one above from you or the one across from the pit lane, somebody sitting there, if devices use the same channel on different networks, it does still contend for the same airspace, which means Wi-Fi has this mechanism built in. So, one device backs off when another one is talking, that sort of stuff. So within Formula One, they use this system called Atlas. We talked about it last time when we were having the session with Mina on multicasting. So they have a system called Atlas, and Atlas is the telemetry coming from the car. And there's race engineers that walk around with mobile devices. Could be an iPhone, could be an iPad, could be a laptop, what have you. That thing is connected. That device is connected through Wi-Fi. So imagine the Wi-Fi not being stable, or it's, the air is congested. You're in for a treat, because there is a chance you won't see the real-time data on your screen, which means your decision is delayed by 10 seconds, which then means that the driver already passed the pit lane, which means he's going to pit one lap later, which may, maybe the tires are already worn, maybe the brakes are already overheating, right? And again, the difference there for them is to make decisions in split seconds and make the right decisions based on the data that they have. So 6 gigahertz, bringing that to Sauber is an advantage for them, because it's not that that's going to make the car run faster, but it's going to make sure that it's one thing less to worry about, and ensuring that the data actually gets from point A to point B in the quickest way possible, without them having to worry that something freezes, like your camera, for example. Right now, I know that's not a Wi-Fi issue, but that could be a result of this. If you're looking at a camera feed and the screen is frozen for 20 seconds, you may miss some very, very important data points, or some very, very important events. Yeah.
It's all about data, isn't it? And the criticality of the timing of that. Well, that's a good chance to just recap on what we learned today. So Roy covered 6 gigahertz wireless technology, how it's evolved over the years. You got understanding that the spectrum is wider now. There's more room on it, but there are some worldwide considerations. And then what we just talked about there is, how does that play out in Formula One environment going forward? We're going to try and demonstrate that for you in the next session. We'll do this later on in the summer, after some of the summer European races, and we'll see whether we can show you that. Like, what is the airwaves actually like in this environment? All right, I'm just going to leave this on screen for a second, so stay with me, because I forgot to mention at the beginning that the slides we've used here today are in a workbook, session workbook, and if you scan that QR code, you can get to a download link where you can get these slides. So if you want to relay these topics to some colleagues, or educate your boss on why you should be thinking about a wireless upgrade to 6 gigahertz, then please download these slides and use them. And what we said is, every time we do one of these sessions, we'll package up the slides. So over time, we've done 3 or 4 of these. You've got a workbook you can refer back to. And remind you of what we talked about. Now, if you've asked any questions in the chat window, then the team is trying to answer those live as we go along. If you're watching this on demand later on, then there may just be a time delay by the time we answer your question, if you haven't asked it live. So I'm just going to wrap up now. Let's just review where we are. So we've finished the session today, but there is a couple of things to call out. Roy already did it for me. We have some other training. So we have a recent live stream we did with David Coleman, who's our resident expert, is the industry expert on wireless. Fantastic that he works for Extreme Networks. And we did a Q&A session with David where he talked about top questions that he's getting asked, and he gave us the answers. So that's in our resources section on extremenetworks.com. You can watch that anytime you want. And he does talk about 6 gigahertz as well, so you can get another perspective on 6 gigahertz and why that is so important. And then just a reminder that this is actually part 2. We've already done one of these sessions, going behind the scenes at KICK Sauber F1. And the first part was all about multicast and why that's important in a high-performance environment. So that's also available on demand. So it's another one you can go and watch if you haven't already. Okay, Roy, I think there's only one thing left to do, and I think we should, firstly, thank the audience. Thanks for sticking with us. Stay tuned for the next one. I think we should leave, Roy, the last word to Hugo. And,
yes,
and let him spend a minute talking about how does he learn and what's his approach to taking on new things. So we'll say goodbye. Thanks, everybody, for joining. And let's leave the last word to Hugo. Thanks, Roy. Thanks to Marco. See you next time.
The first thing I got approached with Extreme at Sauber that we're going to have Extreme, I went to the website. I went to Extreme, I looked what it is, especially the fabric, that we're getting the Extreme fabric with our system. It was intriguing. And so I read some white papers, I read some documentation, and then I found the free training you have there. I did a few sessions and I looked at some information and I got myself prepared. And then the Extreme engineers showed up and we had a good meeting at Sauber. How we're going to plan and how we're designing the network and what's their idea and the way it is and stuff like that. And from there, we had a knowledge exchange and a very detailed knowledge exchange, what can happen, this and that. And it just took off from there with really keen people on these products from the manufacturer side. And of course, the thirsty people in the networking area trying to understand these new technology and how can we maximize the benefit of the system for us and our requirements. So you just got to dig in and learn it.